We introduce Multi-HMR2, a new approach for multi-person camera-centric human detection, mesh recovery, and tracking. Our goal is to recover all human meshes given an image in a single shot. Our model must be able to detect humans, localize them in the scene, and recover their 3D meshes in a single forward pass. We also predict a camera to reproject the results on the image. Prior works in multi-person human mesh recovery include single-shot approaches, such as Multi-HMR and SAT-HMR. However, these methods come with limitations that we aim to address in this work. First, most prior works rely on the SMPL body model that does not allow to model expressive hands and faces. Multi-HMR uses SMPLX, making it whole body. However, HMR methods are still bounded by the limited amount of high-quality expressive training data. A key improvement is child awareness. Unlike the previous two methods, Multi-HMR2 is designed to handle children together with adults. We also improve camera-centric estimation by predicting the camera's field of view, while prior works either rely on a fixed camera model or on the ground truth intrinsic parameters. This allows us to significantly improve the perception of close interactions in between humans. Finally, Multi-HMR2 allows to track the identity across frames while being trained exclusively on still images. In order to make Multi-HMR2 child-aware, we rely on the ANI body model. ANI is open source and covers the human diversity in terms of ages, body types, and proportions. Different from prior body models learned on 3D scans, ANI leverages the anthropometric expertise of the Make Human community and features interpretable body shape parameters such as age, height, weight, or muscles. Here is an overview of the proposed architecture. Multi-HMR2 relies on a DETR framework for detecting humans, making it robust to heavy occlusions and to humans in close interaction. A set of learned queries attends image features extracted by a VIT in a transformer decoder. Each query corresponds to a potential human detection. The selected queries are turned into 3D meshes using the ANI body model. We also predict the camera from the CLS token of the VIT, which allows us to reproject the predictions on the image. Prior approaches use the 3D or reprojected 2D meshes to match the candidate predictions with the ground truth during training. In order to speed up the training process, we propose a matching strategy based on the 2D location, saving us forward and backward passes through the parametric body model. This makes the training fast and memory efficient and usable with data lacking 3D annotations. In order to track identities across frames, we regress features distilled from the SAM2 memory encoder for each human. At inference, Multi-HMR2 can track humans in videos despite being trained exclusively with still images. Compared to prior single-shot multi-person HMR methods, Multi-HMR2 achieves state-of-the-art results. In terms of human detection, pelvis-centric 3D error, camera space metrics, close interactions, 2D reprojection, and tracking. Multi-HMR2 brings us closer to practical, human-centered scene understanding by combining multi-person detection and pose/shape estimation, accurate 3D localization, child-aware body modeling, and identity tracking in a single framework. Our code is publicly available online. Multi-HMR2 is a simple-to-install library that allows you to obtain multi-person HMR detections in real time with a single command in the terminal. It can also be easily integrated into your own code with just a few lines using the Python API. For more information about Multi-HMR2, please visit our poster at ECCV or contact us by email.